myself. Okay, so now this iteration business. Can you guys see what this shape looks like? It tells you to find in the first octant, so x, y, z have to be bigger than 0. Then it says define by z equal to 1 minus x, which is a plane. And then y equal to x squared, which is a cylinder. So the plane, it's basically, if you look at plane in xz plane, intersection of this plane with xz plane, you will see a line. Then there is this over here. That's the cylinder y equal to x squared. And y equal to x squared is perpendicular to the xy plane. Now that you're learning about what is this thing that we learned about, the parameterization of the space curve, you can tell how I drew that one. That's the parameterization of these two intersections, basically. So far, we haven't been telling you that, but now that you learn about it, you can do that. Do you guys want a little bit of a practice on GeoGebra on this parameterization? It's a fun thing to do, I think. I may actually ask you guys to do that. It looks very nice. This parameterization to know is important, is one major way of using 3D printers for exact computations, basically. So to know how to do the parameterizations. And so that's one way that I want to tell you. It's the best way. Now, what the question is asking is the iteration of that in 3 ways. One is dz first, then dy first, then dx first. Let's do dz first. So dz first. How do I go about that? Wait. There is this cylinder, the purple shade that I did. That's like a wall. There is that y equal to 0 that sits behind the wall behind it. So there's a y cylinder over here, and then the other one. There are 2 walls. But they don't, they have nothing to do with restricting z. What is restricting z? This, let's color it in cyan. That plane is the one that is restricting z, basically, right? So z equal to 0 and that one. What you do is for the most inner, you always look at the surfaces. Don't solve for anything. Don't intersect things. Don't do anything. Just, I mean, you need to solve in terms of the variable, but don't intersect the 2 surfaces. Just take the plane surface that you see. Makes sense? And solve for the variable you need. So solve the 2 surfaces, the surfaces for z variable. Do not intersect. That's a common mistake that happens. Do not intersect. Just the most inner, no intersection. Just plain solving. Plain, I mean, simple solving for the variable. So how does that work? The most inner becomes from 0, solving for z in here gives me 1 minus x. Easy. I know I don't have to compute anything because it's the inside is not a function, it's just f, right? It's one of those that do not compute. Now, what I need to do is to set up the 2 outer ones. And I can call it as dx and y. So how do I figure that out? What I need to find is this projection of this shape. That means that if you shine a sun right on that is completely shine lights parallel down from the z direction, you want to see the shadow in xy plane. That's a projection. And so how do I figure that out? It's the biggest area that shadow it creates, right? And that biggest area in this case is just the one that I can see right here. So now it's time to intersect. So what do I intersect? I intersect for this one, I intersect y equal to x squared, this one, and z equal to 0, which this one gives me y equal to x squared. For that one, I intersect x plus z equal to 1 and z equal to 0, which gives me x equal to 1. And then I know the backwards are so I have y equal to x squared, y equal to x squared, and I have x equal to 1, and this is the region. Okay, okay. Now, this is not asking us for the order of x and y. Choose whichever you like. It's already solved in terms of y, so I go with that one, right? So I go with y equal to 0 to y equal to x squared. So this goes away. I have dy first, 0 to x squared, and then x goes to from 0 to 1. Okay, questions so far? We're doing, gonna go a tiny bit faster, I think. What page are we? No. By the way, I have a room reservation until 3. That's until 2, not 3. So I have 3 hours of room reservation, but I know you guys are going to get tired after 2 hours. So let's try to go a little faster. Now, let's do dy first. Let's do dy first. When I go dy first, I look at the surfaces, right? So the first one has to be surfaces. We solve for y, but we don't intersect, right? So solving for y, I can see that in the y direction, this wall is a bound, right? It's something that restricts y. And it starts from 0, goes to that wall. Oh, incidentally, it's solved in terms of y, so I'm all okay. So I put in 0 to x squared for y. Now, what I need to do is to figure out the 2 outer ones. The 2 outer ones are x and z, right? Y is already used. So draw the picture of x and z, the projection on x and z. On x and z, what do I need to do? Now it's the intersection time. For x and z, that means y is equal to, I see that the biggest area comes from when I, on the y equal to 0 plane, on xz plane, right? The biggest shadow that solid it creates is right there. You see that part? Is right there. So what do? I set x plus z equal to 1, intersect that with y equal to 0, but since there's no y in there, it's just going to be x plus z equal to 1. Make sense? So now I have x plus z equal to 1. And then the other ones are these. So far, okay? Okay. Now, it doesn't matter which direction I want to go. Which direction should I go? Z? Yeah. Z equal to 0 in here, Z equal to 1 minus x on top. So dz 0 to 1 minus x. Then what is that point? That point is 1. I need numbers for x. 0 to 1 dx. Sorry, it gets messy when I have that so big. Let's rewrite it. Okay, there. What is left? This was dy first. Now do dx first. That's the only one that is left. And so dx first. In the x direction. Friends, what is causing trouble for restricting x? X, if I'm going in the x direction, I hit that wall first, then I hit this wall, right? I hit the cylinder first in direction x. If I draw an arrow in direction x, that hits the y equal to x squared first, and then hits the x plus z equal to 1. So there are two walls that are bounding x, two surfaces that are bounding x. One is this, the other one is that. So in the x direction, x is between square root of y and 1 minus z. There we go. And so I go square root of y, 1 minus z, dx, and I forgot f right here also. F. And then the next step is to figure out what shape I get. What are the two other variables for the outer ones? The a with respect to y and z. So y and z, I have to look at this projection. That projection is basically the intersection of y equal to x squared and that over projecting on the the other one, x equal to 0, plane x equal to 0. So intersection of those two, what does it give me? X plus z equal to 1, y equal to x squared. And I want to eliminate x in there. So I can get, by eliminating x, what just happened? Why do I not cover this bottom part of? Was it better before? I got worse, I don't know. By eliminating x, what I get is x equal to 1 minus z, y is equal to 1 minus z to power 2. Right? So y equal to 1 minus z to power 2. If I put in z equal to 1, y is going to be 0. If I plug in y equal to 1, then z is going to be 0 right there. Okay, sorry. Let's make this a little nicer looking. There we go. Didn't work. Y and Z. It looks like that. I get parabola looking downward. What? Oh, I'm sorry. This is when nasty things happens, right? So it's y equal to 1 minus z squared. Hold on it. Looks like that. Z equal to 1, right? Like this. There we go. Better? This is 1 and 1. Looks a little like that. Okay. So that's the shape. And this is y and this is z. Now you can set it up however you want. In here, which one's easier to solve? Y is already solved in terms of z. So I go in the y direction inside. So I go y, and y goes from 0 to 1 minus z to the power 2. And then z goes from 0 to 1. Okay, questions so far? We're doing